Sorry, Amber.
What if she doesn't read?
Alright. This is the final lesson in chapter 7. Okay.
That's scary. What does that mean?
It's terrifying.
It's like
What's chapter 8? Chapter 8 is
Oh my gosh, this is where I go down real. Chapter 8.
trigonometry.
Not very.
Alright, so let's finish this one up before we get to trigonometry. This last section is kind of going to be intuitive from what we've already talked about. The first part is just that a line parallel to one side of a triangle separates the other two sides proportionally. So what that means is if I know that xy here is parallel to RS, the sides of the triangle, or the pieces of the sides, are split proportionally. So if these sides are parallel, then I could write a proportion, like Rx over xt. This piece over this piece is going to equal this piece over this piece. Okay, so I don't have to split it up into two separate triangles. I can just look at the portions of the sides of the triangle.
Does it automatically say like that it's no, that it's cut in half? Like the
Not necessarily.
Okay.
So this is true as long as these are parallel. This doesn't have to cut the opposite sides in half. Right? And then the converse, or the flipping of that statement, is also true. Okay? If I know that this line splits these sides proportionally, then these lines are parallel. Okay? So if we look at this example down here, okay, we're told that EF and CB are parallel. From that information, we want to set up a proportion to solve for x. Well, if I know these two sides are parallel, then I can say AF over FB equals AE over EC. So we could say x plus 22 over x plus 2 equals 18 over 6. We could actually also say x plus 22 over 18 equals x plus 2 over 6. Okay? And we could actually flip both of these as well. Right? We could write this one as x plus 2 over x plus 22 equals 6 over 8. Or we could flip both of these. So there's a couple of correct ways to write these proportions. Right? We don't have to write all of them, obviously. And we can even make the math a little bit easier by reducing this proportion. It would just be 3 over 1. Right? So 18 over 6, we can just reduce to 3 over 1 and then cross multiply. So 1 times x plus 22 is just going to be x plus 22. And then we'll have 3 times x plus 2. I guess I'll go ahead and write the times 1. Then distribute. So x plus 22 equals 3x plus 6. The x is on one side. Subtract 6. 16 equals 2x. Divide by 2, and we get x equals 8.
Okay, so what does that turn to just find the x factor? It shows that they're both sides.
Well, not necessarily congruent.
Then what are we getting from that? I don't know, what are we proving?
We're not proving anything. We were just trying to find x in this one. So we were using this idea to be able to set up our proportion, but then the goal was just to find x. All right. Questions on that? So this was 18 over 6,
Oh,
and I just reduced that fraction.
I'm like an iron.
So the other idea that we want to look at is the idea of a mid-segment. Okay? If I find the midpoints, so if I know that x and y are the midpoints of these two sides here, and I connect them, that guarantees me two things. First, it guarantees me that this side will be parallel, or this mid-segment will be parallel to this side. And second, it guarantees me that this will be exactly half of this length. Right? So remember, we talked about mid-segments with trapezoids, and we said that for a trapezoid, the mid-segment is going to be equal to the average of the two bases. That's kind of the same thing here, because if we think about the two bases, well, we can think about this one as having a length of 0, and then this one would be just double this length. So this would be exactly half of this length. It's kind of the same idea as a trapezoid, right? If you think about this being a trapezoid with this base being a length of 0, so the mid-segment will be exactly half the length of the base that it's parallel to. Right? So if we look at this example and throw that idea in here, we are told that, actually I guess this example doesn't go with that. This example goes more with the first part. Yeah, so it's kind of going backwards and saying, we know HK is 5, we know KG is 10, and JL is half the length of LG. We don't actually have measurements, we just know JL is half the length of LG. So from that, we want to figure out, is HJ parallel to KL? Well, if I know that these proportions are true, right? So if I can say, like, KG over KH, if that equals LG over LJ, if that's true, then these are parallel. So KG over KH would be 10 over 5. Is that equal to LG, which all we know is JL is 1/2 the length of LG. So I could write that a couple of different ways, right? We could say LG, or we could write it like this, I guess. If we know it's twice the length, we can say 2 times LJ over LJ. Then, since we're multiplying, we can cancel these things out. I can cancel out the LJs, and I would just have 2 over 1. Obviously, 10 over 5 reduces to 2 over 1. And we see that those two proportions are equal. So what that means is, yes, these two sides, or these two lines, are parallel. So yes, HJ is parallel to KL. All right. So we can go in both directions from this statement. If I know that a line is parallel to a side of a triangle, it cuts the other two sides proportionally. Or if I know that the two sides are cut proportionally, then I can say these two lines are parallel. And if it happens that we are connecting the midpoints of a sides. That mid segment is exactly half the length of the base, and it is parallel to that base. Okay. Questions?
Why did you write 2LJ in over?
So I just took this piece of information. It says JL is 1/2 the length of LG. And I kind of flipped that around and said, well, that would have to mean then that LG is twice the length of LJ. So I just wrote LG as 2 times LJ or JL so that we can show that these two proportions do end up being equal. Other questions? All right, then let's take 1 minute here and try 1 or 2 of these. We don't need to try all 6 of them. Just a couple of them. $132. You did all of them already?
Yes.
Nice.
You were. It was number 5.
5 should be 12.
How about number 3?
Makes sense. 17.5.
I did QX plus 12 plus 33. It wouldn't equal 33.
So you said this whole length would be 2x. So we can say that over 33 equals x over 11. We don't know that these sides are the same.
So we can
say something like that.
we cross multiply.
Yeah, and you cross multiply.
Okay, I didn't use something weird, but I got the same for number 5.
Oh my god.
I subtracted 11 from 33, and I
You just said this was 22.
Yeah.
Yeah, that would
Okay. I had that. I had this, but I got the same.
that would probably be easier than what Caleb did.
I don't know why I'm so confused. what you do,
Yeah, I
x
got
plus 10 over
I got all of these.
So you just have to be consistent. So since you did
I just said that.
30,
I literally just said that. Yes, I
start with this side.
So I got 35 and 65 arrows first. This
Now,
goes
what I know is
down.
that when I did over here and then fraction it more,
No, me, yeah, wait, I wrote 5. I'll beat you this time.
So on number 3, okay, this is the only one that was slightly different than the rest of them. On number 3, we're told that these halves and these halves are congruent, which means these are the midpoints. So since this is the mid segment, it's exactly half the length of the base that it's parallel to. So I would just cut 35 and a half and get that this mid segment is 17.5.